to this computer. Week number 2, chapter 3. We're going to start out by taking a look at something that's going to become a little more important in this course. And as you can see, we're gonna get into more. I'm training you for CPS 162, but I'm also training you to do more thinking versus typing. And what I mean by thinking is you read a program, and then I want you to start to get into a habit of maybe doing this little algorithm writing that's followed by first doing some test data if necessary to make sure you know what you're doing before you take off. So if I said, and this is kind of simple because you all went through 121 and you can look back and see what's going on. But let's say, for example, that second one, algorithm for calculating the average. Okay, let's see. I need sum, give it the value of 0. I need count, give it the value of 0. I need to total everything up. I need an accumulator and I need a counter. So those two values are there to start. That's generic in any language. Do you see how, if you notice there in this one, it's actually an arrow? That's that big right side is being assigned to the left. That's an assignment operator. When not long ago, there was a language being used called Pascal that actually used its assignment operator, a less than followed by an equal sign, to help you remember what's on the right is getting moved to the left. All right, so you're going to read in a number. As long as the number is positive, you're going to add it to the total, add 1 to the counter, get a new number. Nice little generic while loop. Could that be used in any language? If count is greater than 0, you output sum divided by count, else no numbers were entered. So if I handed that to you and said, code it in the language blah, 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 it would be kind of easy because a lot of the thinking is already done. The logic behind what you're trying to solve is already complete. Down below, find the smallest, find the largest elements of an array. We're going to let the first one be the smallest. We're going to let the first one also be the largest. That way I don't have to come up with a bizarre negative 2 million to be the largest. So the first thing is definitely larger than that. I'll just assign it the first value. I come in and I have a loop to go from 2 to 5. If it's smaller than small, it now becomes the smallest now becomes that number. If it's larger than large. Yep. So these are different. They're not really, in depth, but all of the logic and calculations are written down. We're using words like input and output, which are generic. There was a couple in here that you could go about practicing. I found as we go through, you get better at it. Here's one. You put the name, the hours, and the rate. Yada, yada, yada. I go through. I count the overtime. I get the gross. I add the total and gross, and I output everything. While loop. Type in end of data to end. But all my thinking is done. Yay. Greatest common divisor, greatest common factor. Does anybody ever see what's going on here in number 1? While smaller equals 0, do remainder gets larger mod smaller, larger gets smaller, smaller gets remainder. Anybody know what that is? That's called the Euclidean method. If I gave you the numbers 168 and said, what's the greatest common factor? You're kind of doing it, running it through in your head. How's this going to work? But here's a while loop that would actually calculate it for it. Write an algorithm, play the game of craps. So I'll give you a whole bunch of examples to take a look at. But boy, it's nice when all of this thinking is done ahead of time. Yeah, good. Okay, so what we're going to do right now, I'm going to switch my video and I'm going to come over to here. And if I said to you, well, let me get the view to be speaker, me, and wow, cameras are all cattywampus. If I gave you this, said, hey, an algorithm, I want you to write an algorithm to convert seconds to hours, minutes, and seconds. Could you do it? Well, well, test data, right? I'm going to come down here. If seconds equals, let's see, I'm going to go 6. How many hours is that? How many minutes is that? How many seconds is that? Well, that's 0 hours, 0, and 6. Yeah, okay. But I'm already making test data because when the program is done, I know what should the answer should be when I get ready and run the program. What if I do 60 seconds? Ah, should be that. 61 seconds should be that. Uh, what would be an hour? An hour's how many seconds?
60.
60 seconds is a minute. So how many would be an hour? Something like that.
3600.
3,600. Yeah. 3,661. That's one of each. So already I'm thinking, yeah, I got some let's see. I'm going to input seconds. I'm going to find out how many hours. Hours equals, let's see, hours equals. How would I find out how many hours there are? What's 1 hour?
Oh, 1 hour is 3,600
Yeah.
seconds.
So how many hours will be what?
Oh, 53,000 seconds.
Seconds divided by 3,600. Integer division, right? Integer division. Okay. So now I know how many hours there are. I need to eliminate that number of seconds. Seconds. So if it's this number, 3,600, I knew it's 1 hour. How would I find out how many seconds are left after I calculate the hours? Because really I'm calculating the hours, using what's left, calculate the minutes, using what's left will be seconds. So I'm calculating the hour and figuring out how many are left. I'm going to take the number of seconds I have and I'm going to subtract hours times 3,600. There's 1 hour. That's 3,600. I'm going to subtract from my number of seconds. Minutes, seconds divided by 60. How many seconds are left? Seconds minus minutes times 60. Output hours, minutes, seconds. Now, if I said, go ahead and code that, whew, you should be able to quickly do it. Agreed? Agreed? Yeah. Okay, so you start to get the idea. Now, when your programs are assigned the Thursday before they're due, I want this. This shows me that you've actually thought about it. Chances are, if you do this and figure out what the problem's asking for, then this will just kind of flow after a while. You need a mathematician who can do the work. You need a programmer to code it. And then you're going to need like a statistician to figure everything out. That's the big three: mathematician, computer scientist, statistician. Okay. So a little bit of talk about what's going on. I had another one. Yeah, a bag of concrete, or excuse me, a bag of mulch. How many bags do you need? So I'd start out doing, well, I have a length, I have a width, I have a height, and then I'd have something like some sort of total inches. I would calculate out of that. And then I'd have to divide it by 12 times 12 times 12 times 2 to figure out how many bags. So you could start to do a bunch of work seeing what I'm doing here, the test data. All right, now that I have the test data done, I understand what's going on. Now I can write an algorithm. Shoot, now give me the computer. I can type this up in no time. There used to be t-shirts. Programming is thinking, not typing. Okay? Questions on what I'm looking for with an algorithm? The work. It would not be input S calc hours, calc minutes, calc seconds. Yeah, that's not gonna, yeah, that's, I don't know the calculation. I need to think through the calculations before I write my code. Okay, cool. Over on the D2L, let me get this back over here. You should be able to go back to D2L and see that there is something there for you. It is a .cpp program, and it should look something. I didn't hit share. Go back. It should look something like this. Okay. So what we're doing today is we're going to go hands-on. You're going to be in groups doing most of this. You're going to be in groups doing most of it. You have all these little mini things that you have to calculate. You're making a program that's going to have great notes in it. Fantastic notes. I come in and the first thing I do is I go to hit compile, and it does not compile because line 12 should be a semicolon, not a colon at the equal. So if you pulled that up. Line 21, write the code to ask the user for the radius of the sphere, calculate the volume, blah, 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 blah. So I go up to my declaration section in the beginning. As your programs get longer, it's good to have a declaration section so you don't reuse or try to reuse variable names. I come in, please enter a value for the radius, C out, C in. That was from chapter 2. I now need to calculate the volume. Volume equals da 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 da. And then I'm going to have some sort of great C out statement that does all of that. And while I do this, I do compile and run, compile and run. I keep going, compile and run, so that I don't type 80 lines and then see if it works. Should keep compiling as you go. Please enter the value for the radius. Volume equals, and this also says format to 2 decimal places. I believe that jumps you right to section 3.7. I should put, oh crap. Here we go. Now what are you up to these days? Yeah, go to the end. Go to the end. I'm making notes for myself. Section 3.74 formatting, so that it's in there. Oh, display pi to 10 significant digits. The real pi, and you have to format it to look 3.141592653589793. Well, that's 15 significant digits. Da-da-da-da-da-da-da. All right, so how do we do this? Well, group work. I'm making a note. Oh, that's fruit. Group work. Group work. You have one typist. That's it. And again, the typist doesn't have to think. So the first T is typist, Typist. The next thing you have is a talker. That's the person that's going to be taught. Oh, typist, that should have been a blah, 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 so and so and so and so. The third person in your group is going to be someone that has a textbook. What was that? I think it was in the book. I think we saw it in a code listing. Most of this you can find in code listings, but now instead of just typing it, you're thinking it, you're doing a little bit more. So the three T's of group work: a typist, a talker, and a textbook person. What if you have a fourth person? Well, they're going to be a talker, they're going to be a textbook person, but you need at least one person who just sits there and watches and talks. One person that definitely has the textbook out. Asterisk, 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 share or turn on the other T. Turn on your cameras. It's so hard to work in a group when you can't see what the other people look like. You can't get to know anything like that. So today is a big T day. Typist, the talker, the textbook. Turn on your camera. Okay. So everybody understands what we're doing. We have 19 people here. I'm going to make 5 groups just so you can start to get to know each other. One person types. When you are done, upload it to the the discussion board. Why? Then other people in your group can go get it and don't have to type it up themselves. I don't need everybody trying to type all of this in because it'll take forever. You won't get it done. Questions? I'm going to make 5 breakout rooms. You're going to have 3 to 4 people in these breakout rooms. When you are done, like I said, upload it to the discussion board. Then we are done. I will gladly come around and check on your group. I will gladly come if you call me to help answer a question. All right, you're getting to know each other. And action. Yeah, it's funny. From my end, I could see that only 2 out of 4 have their cameras on. I just wanted to come in and double check.
I have a question, if you don't mind.
Yeah.
For the algorithm, come on, it's opening. For the algorithm, sheet. So you want us like answer the questions that is in the algorithm, and then like submit it.
So if you go and check out your first two assignments that are due next week, each one of them asks for an algorithm first. That'll be submitted by Thursday.
Okay.
And then the
Okay.
programs. So I'm trying to force you to do a little thinking about the algorithm first.
Where do you want us submit it? Because I didn't see a Dropbox for it.
Dropbox assignment one.
Okay.
Yep.
Okay. Thank you.
You're welcome.
And then you basically have to like they give you prompts, so it's like write this code that does this. That's what the code is right now. Do you
Who's
see
going
the link for it?
Who's going to share their screen?
I am.
All right, cool. Cool.
Mhm.
Ryan, you good?
Yeah, I'm alright.
Are you sure? You're waiting for me to leave so you can finish up with Brandon. I know. All right, I'll let you guys finish up.
All right, thank you.
Still don't know what a code listing is. Ask somebody in your group to explain it to you because I have a couple people that did not get the code listing submitted or get them correct.